Welcome to Unit 10, Lesson 1. Today we'll be learning about the Pythagorean theorem. So that should be the title on page 113 of your interactive notebook. Page 111 is for the 3 vocabulary words you'll need. Since we have to have a triangle to learn the Pythagorean theorem, the first step is to glue the 3 squares onto the page in a way that forms the triangle we need. I'm going to show you how first, and then you should pause the video to do it in your notebook. First, we're going to put the smallest square about halfway down the page with the left-hand edge right up against the red line and the bottom edge on one of the blue lines. Then we'll put the next largest square so that the top is right against the same blue line that the bottom of the small square rests. Finally, the edge of the big square forms the remaining side of the triangle. When you're done, it should look like this. Now, pause the video to get this glued in your notebook. Once you have the triangle in place, we have to label the sides. We're going to label them A, B, and C. But we'll start with C, because that's always the easiest one to label and the most important. The longest side of the triangle should always be C. Then we usually label the smallest side A and the next smallest side B. The Pythagorean theorem has 2 parts, and we're only going to do the first one today. The first part says that if the sum of the squares of the 2 shorter sides of a triangle equals the square of the longest side, then it is a right triangle, a triangle with a right angle. Make sure you get that in your notebook. If you need to pause the video to do it, go ahead. Since we've labeled the sides, we also have another way of saying the same thing. If a squared plus b squared equals c squared, then it is a right triangle. Make sure you write that down too. Over the last 2,000 years, you have to remember that the guy who thought this up, Pythagoras, lived over 2,000 years ago in ancient Greece. Over the last 2,000 years, people have come up with lots of different ways to prove the Pythagorean theorem. Even one of our American presidents came up with a proof. The easiest proof to show you is this one. Now, I know that these are already right triangles. In fact, these are the same right triangle, repeated 4 times, and put in the middle of a square. If the smallest side is A, then the area of the little white square up here is A squared. Since the next smallest side is B, that means that the area of the bigger white area is B squared, because the area of a square is A times A, or A squared, and here B times B, or B squared. So the total white area inside the bigger square is A squared plus B squared. Now let's move the triangles around. I'm going to slide this one over to here, and this one down to here. And finally, I'm going to slide the yellow one up to here. Now, that white area in the middle has to be the same as it was before, because we've just rearranged things. We didn't make any more white space. But how big is that area now? Well, now that area is c squared, because the longer side of the triangle is equal to c, and the area of the square is c times c, or c squared. So you can see that they are exactly the same as before. But you can also see that because the white area is a squared plus b squared, that a squared plus b squared has to equal c squared. And the reason this is true is that my basic triangle here is a right triangle. It has a right angle. Let's go back to our page 113 and see what it means. If a squared plus b squared equals c squared, then we know we'll have a right triangle. How do we find out? We write it down. A squared plus b squared. Does it equal or doesn't it equal c squared? First thing we do is we're going to label the sides of the triangle. We've already done that. So the next thing is to substitute the values for the variables. A is 3, so we're going to substitute 3 for A. B is 4, so we're going to substitute 4 for B. And C is 5, so c squared becomes 5 squared. That's our third step. First we label, then we write the Pythagorean theorem, and then we substitute. Now we do the math, and the order of operations tells us that we have to do 3 squared first to get 9, and 4 squared to get 16. Then over here we do 5 squared to get 25. And finally we add them together to find out if we got 2 identical answers. And if we did, that means that we have a right triangle. Since we have a right triangle, we can go ahead and put in the labels that we learned in our vocabulary. The long side is called the hypotenuse, and both of the short sides are called the legs. Make sure you get those names into your notebook as well. We can do this for any triangle, right? We don't know if it's a right triangle or not, so that's what we're going to find out. First, we're going to label it. The long side we do first is C. A is the shorter side, B is the next short side, and then we write the Pythagorean theorem. Substitute in the values for A, B, and C, do the math, and add it together to find out whether they are equal. Once again, this is a right triangle, and we can go ahead and put in a square that indicates that it is a right triangle. But suppose we have a triangle that has 2 sides that are the same. C has to be our longest side. Which one is going to be our shorter side? A. It doesn't really matter. As long as you get the C right, that's the most important thing. One of the other sides can be A, and one of them can be B. It doesn't matter as long as you get C right. Now we substitute the values, do the math, and figure out whether or not A squared plus B squared equals C squared. If they don't equal each other, our answer is no. It's not a right triangle. We can do this even when the numbers get much larger. Here you see I have A of 409.5, B of 453.6, and C of 460.6. We do it the same way. First step, we label. Second step, we write the Pythagorean theorem. And you can just write a question mark in between if you like. Third step, we substitute the values. Fourth step, we do the math. And the fifth step, we compare our answers. Once you get that, you can say, no, this is not a right triangle.